miscellaneous embedded systems conference.
Good evening. Welcome to the April Tax Day meeting, and I want to thank all you. Either you all know how to fill out the extension forms, or you're all really on the time and have your taxes in right now.
9:30 this morning.
9:30 this morning. Do I hear 10? 10:30? What are we going for?
February next year.
Oh, February of next year, okay. I'm going to make it by August 15th. I swear to God, I'm going to make it by August 15th. Okay. I'd like to report that there's been over 31,000 downloads of previous talks that have been given here, so it still continues to be a very good spot. We're getting about 1,500 reviews of previous talks every month. We are recording tonight's meeting again, as we have the last couple of months, and it should be available within a matter of a few weeks. How many people here have actually looked at one of the recordings? You don't have to. You came here, of course, so it's not really important. But we do get a number of people looking at the recordings, and we appreciate being able to spread it around the world. I'd like to introduce our speaker tonight. Our speaker tonight is Christian Kurzke. Who is a fellow German. I had to tell him my name was Selmeier one time. He got his master's in computer science from Erlangen in Germany. We were trying to figure out earlier if that's the same Erlang as the Erlang distribution, and we haven't really come to a complete decision on that. But he's been very, very active over here in embedded systems and the kinds of things we're going to talk about tonight. He was the designer and the embedder of the web server in VxWorks, the Internet Suite. He went to Sun following that and developed the Java embedded server, which is part of the OSGi platform. He led the specification group that did the OSGi UPnP integration specification, and he has, since he has left Sun, been with Gatespace, which is one of the founding members of the OSGi, a spin-off from Ericsson, and a company that has just recently gotten some favorable press for creating an intelligent house in Czechoslovakia, if I remember right. I think it is right. But
I think it was in Sweden, but maybe there was another one.
There's another one in Czechoslovakia. It talked about the Eastern Union, and it talked about Czechoslovakia in particular. It's on the OSGi front page, so I hope it's right. So without any further ado, I think we're really talking about an area here where we're going to greatly expand the number of things that can connect to the net, and OSGi is really dedicated to making that a more simple and a more straightforward process. To tell us how they're going to do that, Christian.
Okay. Yeah, thank you for the introduction. And I'll try to answer as many questions as everyone has in the audience. So if you people have any remarks, questions, or something, it's a very small forum. Feel free at any point to just raise your hand, interrupt me, ask questions. I didn't really know exactly how technical and what the audience is going to be, so I have one very high-level marketing presentation, which I think I'm going to spare you people with, and then I have the technical specification overview. So before I go into the actual specification overview, I maybe just summarize a little bit what OSGi as an organization is, where it came from, what it's trying to accomplish, and as Bill already started explaining, OSGi, it's today, most people that look at OSGi see it as a way to create intelligent homes, create intelligent gateways to connect different devices. And this is one of the aspects that you can do with OSGi. OSGi stands for the Open Service Gateway Initiative, and it was started, I think it was late 99, yeah, I think it was late 99. And the founding companies were, amongst others, Sun Microsystems, where Joe Bassi, who's also in the audience here, and I worked together. He's sitting right here. He was, back then, he was the VP of marketing for OSGi, and I was working at Sun in the Java embedded server team. The other companies that were part of this was Ericsson, Oracle, I think IBM was also there from the beginning. And it grew from there on, but the initial starting point was the product from Sun called the Java Embedded Server. And this was an embedded framework for Java applications. So Java applications, embedded Java applications, back then there weren't too many. This was the time of personal Java. And what the Java Embedded Server, the concept that it was designed on is to be a modular framework where you can plug in different components. It's a little bit of the architecture, for example, something you guys are more familiar with is, for example, how Apache is designed with all the different modules that plug in and communicate with each other. And back then it became more or less apparent that this framework can be used for more things than just building an embedded Java-based HTTP server. So Ericsson at this time used it in a product called the E-Box, which was a very early residential gateway type of thing. It was I always call it the intelligent Ethernet cable. It's one Ethernet cable in, one Ethernet cable out, and it runs a 486 processor with about 16 megabyte of RAM. And what they did is they put the Java Embedded Server framework on the residential gateway, and they used the capabilities of the framework to actually download new application modules onto the gateway to execute on the gateway. So the concept there was to have kind of a small embedded application server on your home gateway, so you can execute applications locally in your house. From this on, this back then, they started together with Sun to work and improve the specification, and then it became kind of an open standards body because Sun and Ericsson decided to open up this forum so that other companies can contribute and also developers can actually develop services for this platform. And they started very briefly, it was called the Connected Alliance, but then from there it more or less transformed itself into the Open Service Gateway Initiative, which was started as a non-profit standards organization to kind of maintain this. And it has grown. In the meantime, there was at one point, I think there was roughly like 80 companies, mostly companies from the, there was at a time there was like energy management companies, there was some interest on this side, but it's mostly companies around home networking right now. It's like, well, obviously Ericsson is still a part of this, Motorola is now in it, so the gateway manufacturers are in there, and there's also a lot of the infrastructure companies in there. So right now, OSGi is like, has released it's about to release the third version. The second version of the specification has been released about a year ago, and it's an open specification that everybody can go and download. There is a reference implementation which is available, and there's also products from companies like Sun, IBM, Gatespace is one of them, and others like Process who offer implementations of the specification. History of a little bit of where I come from, Gatespace. After Ericsson more or less founded, or after they started the Open Service Gateway Initiative, Ericsson spun off the group that did the intelligent home networking into a separate company that they called Gatespace. Gatespace was founded in 2000 in Sweden as a spin-off from Ericsson and a research lab called CRNT. And in 2001, we started the Gatespace Inc., which is the American side of Gatespace, and we're located up in Palo Alto. And that's when I joined Gatespace from Sun. So I've been with the OSGi from the beginning at Sun and then at Gatespace. That's where I am right now. So with all this background, I just start diving into the technical slides here and explain a little bit the background of what OSGi, how it is implemented, how it works. So the OSGi service platform, that's the core of the specification. And the platform is a component framework which is more or less designed to implement generic applications which are component-based. They are distributed over either different components or also different physical gateways or different platforms. It's designed with high reliability in mind. You don't want to have to restart your gateway. It's designed for a wide range of devices, so that's why it was chosen to be based on Java. So it's independent of the operating system and the processor. And it's designed for collaborative applications that share resources, share services. As I said, it has been created by a body of industry leaders. I think the most famous ones are Sun, IBM, who are pushing from the Java technology side, and then other companies like Ericsson contributed knowledge. And the specification 2.0 is currently available at the website OSGi.org. The other thing that I want to mention about the framework components is that it was based in, it's very different. If you compare it, for example, with other approaches, for example, the browser approach that loads applets, or the mid-P approach, what we have at cell phones right now, all those applications have been designed with the, more or less with the principle that the Java virtual machine is so you load the code, you start the virtual machine, and then you execute the code, and when the code is done, the software shuts down and the virtual machine shuts down. The OSGi framework was designed so that the virtual machine just keeps running. When the device boots up, it starts up the virtual machine, it starts up the framework, and then all the applications just get loaded and unloaded from the framework. But the virtual machine is assumed to be just up all the time. This means also you have to be very careful with not accumulating any resources. Java by itself is, I mean, it has all the garbage collection mechanisms, so it should be safe to not leak memory. Although when we implemented this framework, we found many interesting bugs in current VM implementations, because most companies don't really run a VM for weeks or months. So, but you also have to be careful to not accumulate just objects like in a hash table, just keep stuffing them in. So this is one of the differences that differentiates an OSGi framework from, for example, a mid-P application loader as you have them on your cell phone right now, or the MHP framework, the multimedia home platform. Then, other than the framework, the OSGi specification specifies a number of standard components which are expected to be useful for most application developers, and so that you can develop applications which are portable between the frameworks. You not just need the basic infrastructure, but you need also standardized services on top of this. So I will talk more to most of them here. That's just a quick overview of kind of services which exist. Some that I want to mention here specifically is, for example, the HTTP service, which is kind of the, well, sort of legacy, but it's also very useful from the old days, from the Java embedded server. So every application that runs on top of an OSGi framework can assume that there is an HTTP server service available. What actually the term service really means, I'll go into this later. It's a special OSGi. It has a connotation within OSGi, but it basically means there is an API available which allows to publish HTTP pages, which is specified. It also has the device access specification, which defines a number of services which are optional, but if the package is implemented, then that's the way how to do it. And this allows, for example, to very intelligently detect new devices and find software drivers for it. The other ones are, they become apparent as we go through the presentation. Then, okay, the design goals, again, it was, the biggest priority is it's supposed to be reliable. We want to have large-scale deployments of home gateways that are running 24 hours a day. You just can't afford to reboot 1% of them every day, because that's a lot of gateways when you have 100,000 gateways out there. It's very important to be portable. It's expected to, like third-party developers will port this to various number of embedded devices, and as most people of you might know, embedded devices, I mean, there is no real standard. Every device looks a little bit different, and drivers are different, and so it's important that this is portable. One of the points which attracted me most to it was has a very high emphasis on dynamic nature. So the framework is very dynamic. Each application is expected to handle, for example, that other parts of the application are loaded or unloaded. For example, if the resources are getting a little bit tight, the framework might actually decide to unload some of the services that were previously available, which gives interesting problems when you have dependency on this. So there is interesting coding going on. It's amazing how much I've learned about Java in those years. Security is also very important. First of all, those modules potentially come from different sources. We want people to implement to this API. So one service provider might deploy applications that consist of services from, you can think of a service for now as like an application module from different sources. So it's important to protect them as good as possible from each other. And it's also important to kind of guarantee a certain quality of service, which is another buzzword. So scalable, well, there will be many different versions of OSGi gateways. There is very lightweight ones, which in this case means something like 2 megabytes RAM, something like 4 to 6 megabytes, 2 megabyte flash, 4 to 6 megabyte RAM, up to, say, OSGi gateways, which have 16 megabytes of flash and, say, 32 megabytes of RAM, which is pretty good for an embedded device. And we have, all the members of OSGi have very different views on where they want to go. So some people see it as strictly for homes. Another big market for this is actually now in telematics, especially in Europe. People are starting to put OSGi gateways into cars to do dynamic deployment of applications, navigation services, or other things in cars. So it's very important to be scalable. The core functions of the framework is lifecycle management. This is really the very core. So we have this OSGi framework, and all the applications come in as, I don't know how familiar you are with Java programming, but the form they are packaged is as a jar file. So applications in individual jar files can be installed, they can be started, they can be stopped, they can be uninstalled, and they can be updated. And this is really one of the core functions that the framework performs. On a more technical level, what actually happens is each application, each jar file gets its own class loader. So we create dynamically a class loader for the jar file, and then we load it, and this guarantees us a separation between the different bundles, classes normally that have been loaded through your own class loader. So each bundle can only access its own classes and the framework classes.
When you have the gateway, I'm assuming there is going to be like a Java virtual machine there, right?
Yes.
Like, is it like standard like JRE that comes with, like, you know, for example in like JDK 1.4, is it like very much customizable one for each device, the gateway?
Okay, so the standard OSGi platform is designed to run, it was designed to run on pjava, and today the most common virtual machine is CDC foundation profile or personal profile VM. But it also runs on every standard, just JRE 1.4. But the subset of classes that it's designed on is the personal. It's actually the personal Java plus the fine-grained security extensions. So it's the personal Java 1.3 specification.
What's the size of your typical size of your virtual machine? Like, you know,
There is different virtual machines. So I know, for example, one embedded virtual machine which comes with Wind River. It's the Insignia Geo. This one, the virtual machine itself is approximately 2 to 4 megabytes. It's a just-in-time compiler, so it needs a little bit more RAM when it executes. I also know Sun has now just released their latest virtual machine, which is an implementation of the CDC hotspot. And this VM will be somewhere around, I think, 1.75 megabytes for the VM. So typically you want that, and then you add the operating system overhead, pretty much about a megabyte or two with libraries. And then you get to a typical configuration of about 4 megabytes of RAM is like the minimum, unless you do some really funky tricks. because you can slim down the virtual machine, you can strip out classes, but then you're not really compatible to the Java standard anymore. So if you want to go at 2 megabytes, it gets tricky there. So I recommend 4 to 8 megabytes of flash, and then somewhere between 8 and 16 megabytes of RAM, just to have a little buffer to execute. So, okay. So then, so I have answered your questions? Okay. Other than the dynamic loading and unloading of applications, as I said earlier, normally each application can only access classes within its own class loader. So this would mean we have one virtual machine, we have a number of applications running on top of this, and they cannot access each other. So in order for them to communicate with each other and do something useful, there is a registry in the framework. You can picture this as kind of a whiteboard. So each application can put instances of objects in this registry and annotate them with descriptive strings, what it is and what it does. And they can share, they can look up, you can publish and you can look up objects in this whiteboard registry. And that's the way how applications share objects between each other. Because as soon as you have the reference, you can call into it and you can invoke methods which then operate in the other class loaders. And this is also a way how we can guarantee security, because that's the only, if this is the only way how one application can access another application, you can put pretty good mechanisms in between to protect them from each other. And it uses actually the Java 2 security model to do this. Then we have package and version management. This is just a way to keep track of different versions of applications. There might be different versions of log servers, so the framework keeps track which version is installed, which version you're looking up. And then we have the remote management architecture. That's another feature that has been designed from the beginning, is to make those devices are expected to run more or less headless. So we didn't initially target so much the set-top box market, which has a graphical display, but it's more targeted towards the headless boxes, which you either interact locally with a web browser, that's the HTTP server for, or you assume they're completely remote managed. Typically that's something, you're somewhere in between. You have some sort of local access, but most of it is going to be remote managed. And the other paradigm is we have a very strict separation of specification and implementation of interfaces. So it uses the Java interface description a lot. So the reason for this is that one application might, for example, require a service that does database lookups, but it doesn't really care which database it uses. So it wants to have basically a defined interface for all the methods, and then you can have different implementations behind this, and the application doesn't really know which one it is calling into. It doesn't need to care. Why did we choose Java? Well, first of all, the choice was made because there was embedded systems. There is like a large variety of processors, operating systems. Every company has their own little proprietary operating system for home gateways nowadays. Some people use VxWorks now. Recently, some people have started using Linux. I've seen BSD. There's all kinds of stuff out there. Java gives a nice abstraction layer on top of this. Then also, Java was designed with security in mind. It's actually not on this slide, but also Java. Basically, Java was designed as a language where applications can be loaded over the network. The whole dynamic loading of bytecode through the class loaders, these concepts were all inherent to Java at the time.
Unfortunately, although it was designed that way, it hasn't always been implemented that way.
Mm-hmm.
Do you have any protections to cover up those missteps on the way to an implementation?
Well, actually, I must say, most of the applications break when it comes to class loaders. Because I agree, most applications or most Java virtual machines were implemented and they never really tested the class loader feature. We found bugs in most of the major VMs. We found actually a lot of bugs in the IBM OTI VM, but we also found a lot of bugs in the Sun VM, which we, fortunately, when I was at the time at Sun, in-house cleaned up. But And unfortunately, I must also admit, there's a lot of people out there who don't understand class loaders and who call themselves Java architects, and they actually implement or design APIs. It's even worse when they start designing APIs and don't know about class loaders. So, for example, if you look close at the Java, I think it's a part of the Java 2 API, they have the Corba API defined, how you should like define, which one is the example? I don't know, somewhere there, I think it's for the orb implementation. You actually specify, you hand over a class, which you basically hand over a reference to a class. And you don't know, if you use an OSGi framework under this, you can't always guarantee that the core framework that you're calling has access to your own class loader where you came from. So this unfortunately crashes. And you have to go through big lengths to circumvent this and wrap it up. But most of the times you can implement most of the things nowadays. And I mean, we have had OSGi frameworks running for the last 3 years now. So most of the mainstream VMs are capable of doing this. Like I haven't tried recently, but I know that Cafe, for example, had problems with this. And I never really bothered fixing it. I reported them, but people don't really use it, so it kind of got forgotten there.
I have a question. The framework, like now, the first slide you had shown, it seems to me, I work with Corba a lot, kind of working with J2EE. So, I mean, like now the underlying framework seems to be like more like our bunch services are like, like the Corba services you have. I mean, like conceptually, that seems to be similar, right? In a way, like, I'm assuming like, just as a crude comparison, like gateway is more like a proxy in Corba, right? I mean, like it is like agent sitting on some setup box or whatever. Then it's going to interact back and forth, right? The reason why I was asking was like, because if I suppose I develop some application using J2EE and then I deploy them like as a service, then most likely whoever the end user is going to be like, he's going to go from the browser, and then he's the one who is going to initiate the call and then like, get the data, right? Whereas in this case, it seems like, you are pushing some sort of like, object, which is going to be like a service onto the over the network, and then like, gateway is going to execute, right? So it seems to be like a lot of event management involved. Because like, the gateway is listening on a particular port, and then like, from client side, like some application, some modification made or whatever, that's going to come over and then you're executing there, right?
Okay. Let me see if I understand the question.
Yeah, the question is like how the event management is being done. Is it similar to J2EE event management, or is it more like similar to Corba event management?
It's more similar to J2EE because so OSGi was not really defined to actively like marshal and unmarshal objects and like move the object instances across from one platform to the other platform. It's more like taking an application and then like as a jar file and deploying the jar file to both frameworks and just running it there. But it's more like a J2EE in the sense that it has a framework where you can deploy different jar files and then they can get, it's an infrastructure for them to find each other and cooperate there. And with the management approach, it's more like you download a whole application. It's not like on Corba, as you were saying, it's like where you push around simple or like individual objects. It's more like you push a whole application to this, or components of an application. But it is very much like, so the one thing that it has in common with Corba is that it abstracts the interface and the implementation. And in this case, the interface is defined as a Java interface, and the implementation is just, bytecode.
So is it like RMI ideal kind of thing?
It is similar to RMI, but the interaction between the, we were actually thinking about this a long time ago. The interaction between the individual modules is a local object call. So it's not designed as that the individual modules can reside on different gateways. So they cannot, so it's just, you have the object reference and you call it transparently. we tried actually we tried a way back to use RMI for this, because this would have been really great for RMI to make it even more transparent. There would have been some overhead in terms of cost, because it obviously is more, well, it costs you more the method call when you do it through RMI, even when it's local. But then the other problem is, the main problem why we dropped it is when you register a servlet with the HTTP service, for example. So this is like, okay, this is not really low-level information. So when the HTTP service has an interface that allows you to register an object as a servlet, and the servlet interface wouldn't allow us to use RMI because there would be callbacks in the other direction, and this would have failed basically with RMI. So this was the main reason why we had to drop it, and we were sorry about it because it would have made a lot of sense. So yeah, that's a good question. Yes?
As for the VMs, might that be Oracle OLE? Would that fall into that category?
I haven't tried it. Do they have their own VM implementation?
I'm not quite sure.
I don't know.
It emulates it's a look-like machine.
I don't know if they have their own or if they use somebody else's.
I don't know.
Yeah. So, yeah, the other reasons for Java were, it kind of prevents people from doing stupid things. It ensures integrity. It's actually a mature platform, and it's getting actually even more mature. So I must say Java for those applications, it has actually, in the beginning there was some problems, but now Java has matured quite a bit now. And there is a pretty wide developer community, because there is a lot of people who picked up Java to do desktop applications, and it's easier for them to write embedded applications than it is to learn about real-time operating system stuff and write embedded real-time operating stuff. That's nasty. And you have a large available code base. The problems that we ran into is, well, integrity, meaning it's not, the model that we have with the OSGi applications, it's more a cooperative model. It reminds me always a little bit what Windows did back in the old days with 3.something, 351 or something. As I said earlier, the isolation that we have right now is we use the class loader for different applications, and we keep track using Java 2 security. But it's not like, for example, an operating system process where you can make real guarantees and you can say, okay, this is only supposed to use up so many megabytes of RAM, and if it uses up more, then I can kill it. In Java, you can't really limit the memory consumption of anything. It's like, there's always more memory. You can always create one more object. And if one application misbehaves and, like, for example, allocates a lot of resources, this might actually start other applications. And you also cannot really force shut down anything in Java. It's like you can kill a thread, but it doesn't mean that it really has to stop. It can always do something weird, override the finalizer, or do something funny. So the model is more a cooperative model. So although we said initially we want to deploy components from different manufacturers or from different sources, those components should be checked and guaranteed that they don't do anything nasty. The security that we use to isolate between different tasks costs a little bit of performance, but that's probably worth it. Well, we have the overall performance overhead or performance cost of Java, which, with processes getting faster and faster, it's probably not as big an issue anymore as it used to be. We have been running this on 80 megahertz 486 processors. The advantage is for those embedded applications, people don't expect a 20 millisecond response time. It's like stuff gets loaded through the browser anyways, and things are typically not as critical as on a desktop system. Size is an issue. I've addressed this earlier. We range somewhere in the 4 megabyte range. And lack of resource management. Again, it's not an operating system. Although Sun has kind of put many features of operating systems in there, they haven't done a particularly good job So next, after this more or less general overview, I'll give a little introduction of the individual entities here. So the entities in the framework is obviously the OSGi framework itself, the OSGi environment. Bundles is one entity. So a bundle corresponds to a jar file. So this is like about the granularity of an application module. So a bundle is somewhere between a DLL file and an exe file, if we compare this to the known Windows world. Services are the interfaces between applications and between bundles. So in the known world, this would be, for example, the Corba interface description, or this would be the RMI interface. Filters, registry, it's LDEP-based syntax. There is a heavy use of events. So the framework, there is many events that the framework can generate to notify those individual bundles. And there is security mechanisms in the framework. So a typical environment looks pretty much like this, where we have the hardware, we have the usual driver operating system stack. On top of this, we have the virtual machine, and we have the OSGi framework, which, just to put this a little bit in perspective, the OSGi framework itself is approximately 100 kilobyte bytecode. So it's a decent-sized Java application, but compared to the 2 megabyte for the Java virtual machine, it's actually smaller than shown here. And then the individual applications come in form of bundles, which are loaded and unloaded through the OSGi framework, and they can look up or publish services which are stored in the OSGi registry. Also, a bundle has access, of course, to the OSGi framework functions. It has access to the regular Java VM features, can open networks. There is no real restrictions on what a bundle can do, other than through the security manager. And then it can also contain native code and access the operating system. As I mentioned earlier, the goal is to have multiple applications to share a single VM, which is kept running. It's considered as almost like part of the operating system. It manages applications, specifically the life cycle, the packages, it handles security, and it also handles dependencies between applications. It provides a registry for services to collaborate. So it provides a service registry for bundles to collaborate by exchanging services. And it has an extensive notification mechanism. As I said earlier, events are very widely used. The other remark is that it's policy-free. So this means that there is no management policies or security policies as part of the framework, but those are extended as separate modules. So there is management bundles and security bundles which handle this. So this allows the framework to be as generic as possible. This is a very simple view on, okay, so the colors don't really come out. That's a very simple view of what OSGi framework would look like that has 3 bundles running. And in this graphics, a bundle is drawn as a circle, and then the triangular things are services. So, for example, bundle B publishes one service, and bundle A interacts with the service by looking up the service. And while bundle C publishes 2 services. So this is just a little bit the notation of how it looks like, and that's the interaction also between the bundles. Here again, to summarize, a bundle is like a Windows exe file. It's an application, but actually, I would say an application consists more of one or multiple bundles. It's not really defined, but I would say a bundle to me is the smallest unit of delivery that you want reasonably to update or change later. A bundle can register 0 or more services. So a service for a bundle is like something that somebody can interact with. So a bundle that does not publish any service doesn't allow anybody else to interact with it. It might still be useful by interacting with other bundles and looking up services and using them. a service is defined as a Java interface and may be implemented by multiple bundles. Then we can use searches to find services registered by other bundles. So a bundle can look up other bundles by query with an LGAP-like syntax. As I said earlier, the registry allows to annotate the object with strings. We can query those. And the framework itself is only another bundle. It's the system bundle. So again, it's a jar file. The jar file is annotated with an extended manifest, which defines dependencies on other resources, and it also defines additional name, description, copyrights, and so on. And then it defines an activator, as we call the bundle activator, which is called to start and stop the bundle. So, okay, I don't know if this is on any slide. I'll just mention it here. Basically, the dependency between bundle is that in Java we have different packages, and as I said, a bundle typically has its own class loader. It accesses the classes that it brought with in its own jar file, but it can also access other library bundles. And so I've always talked about importing and exporting services. We can also import and export packages in a controlled way. And if a bundle depends on another package, for example, there could be, say, the serial port package. It's not part of the standard Java environment. There is a bundle which implements a serial port, and it exports the package, whatever, javax.com. I don't know what it is, serial. And this exported package would be stated in the manifest of the exporting bundle, and everybody else who needs this bundle can state it in the import statement, and then this bundle can only be started after there is somebody found who is exporting this, so the dependency is satisfied. So those dependencies are actually evaluated before the bundle is started. And then starting a bundle, well, regular Java files or Java applications have a main class that is like just a standard interface, and you know when you write a main class, that's the first thing that gets called. An OSGi bundle needs a class that implements the bundle activator interface that allows it to start and stop. And the name of the class can be specified in the interface so that it's found. So we don't have a strong naming convention. It's just a class that we put in the manifest. And as I said, it can also act as a library, like a DLL file, and only export something and not be active. Yes?
How would you version control various bundles? So let's say in your example of the serial port bundle. So let's say the system currently has one bundle, and there's either an upgrade, or you may have two bundles that, through whatever dependency, may refer to different versions of that.
Yeah. That's an interesting problem that can arise there. So the standard how it works today is that if two bundles export the same version of a library, then the first one is chosen, the first one that shows up. If they export different versions of it, and that's actually something that's going to slip into the version 2.0, 3.0 I mean, they will actually have different, for the major versions of the software, they will have different packages. So you can export one that implements 2.1 and you can export one that implements 3.0, and then both of them get installed. But the tricky part with packages is that when a bundle exports a package, it states which version number it is right now. And the way the framework is implemented today, if you install bundles, I mean, the order in which we install them is typically defined by the management system. Yeah, I'll come to that later what this means. But basically an external entity starts and installs and starts the bundle. And if this management system, for some reason, installs, it can be that several bundles, say for example you have an X10 bundle, which brings its own serial port package, and you have, I don't know, some other security camera bundle, which also has a serial port package. And whichever one you install first, even if the first one has the lower version, this package is put in the framework registry as exported, and then the second one that comes along, say you install your X10 first and it has a version 0.9, and then you install your other security camera package, which comes with a serial port version number 2.x. The 2.x one gets ignored, and instead it actually imports the 0.9 from the first bundle. And this can lead to quite some confusions if the second bundle actually requires some features of the 2.x bundle or 2.x package. So that's why with the upcoming 3.0 release, this was actually addressed, and for different major numbers, they have different different versions of it installed. Because the problem is, you need, from a Java perspective, you need to agree on one particular package that everybody uses. Because if you would let different bundles use different versions of the same package, you would get very interesting class cost exceptions. Because you could have an instance of serial port, which is loaded through the one bundle, that you try to assign to, or try to compare with an instance of serial port that was instantiated from another package, and you compare two instances of serial port and you get a class cost exception because they have been loaded through different class loaders. And so it was a necessity to figure out which one to use, and unfortunately it was chosen to just use the first one that comes along. Yep.
So what kind of requirements would there be for provisioning back-end servers to provision these bundles to, say, over a wireless network to an OSGi platform someplace?
Okay. Yeah. I'll just answer this one. I think there's a little bit information in the slides later, but OSGi traditionally was based on an API specification. So, I mean, there's other standards bodies, like, for example, DOCSIS, who do protocols, or, I don't know who does WML or web. But OSGi is strictly API. So there is no management protocol that a management backend could talk to. But instead, there is a management API on the framework. So what you would have to do is you have to install a management bundle that talks your specific protocol, and then this can talk the management API to the framework. So this bundle would sit as like a kind of a proxy on the gateway, which knows how to get in touch with your backend system. The problem is how it gets there initially.
Right. That's my point. I was thinking more of JSR 124, which is a provisioning spec, sort of, for provisioning servers. And I know they're targeting OTA, over-the-air provisioning right now for mid-peak time devices. Yeah. But I'm looking at CDC-like devices and OSGi bundles. How would they target that? And that's, I guess, my question is there a...
Yeah, I mean, for like JSR 124, I actually haven't read it in detail. I was pointed to it like a few times now. I finally have to stop and read it. But yeah, so the idea how this would work in an OSGi world is that when you initially assemble the device and you put the OSGi framework on, you just put basically on the flash of the device, you put a JSR 124 bundle that knows how to get in touch with your Java vending machine backend and talks the appropriate protocol, and then you could integrate it. The other thing that maybe I should clarify here, because a lot of people always get scared of the O in open. I mean, everybody here hopefully knows that open doesn't mean that everybody can do everything. It just means the specification is open. But I know like 2 years ago or so, I was talking to people in the cable industry about those OSGi gateways, and they were scared, like really. I mean, they were badly scared, without using any bad words here. And because their fear was that, oh, we're going to deploy OSGi gateways to those houses, and then people start just downloading random applications on them, and it's like a free-for-all platform, and everybody can install whatever, and it's going to be this big chaos. But no, an OSGi platform is not really open so that everybody can install everything. It's like, it's a programming platform that's an open standard, and people can use it to build closed proprietary gateways. If you put a management bundle on it that only talks, say for example AT&T deploys this, and their management bundle only talks to the AT&T backend, it's completely under their control which bundles get downloaded to this framework. And if you have another service which you would like to provide to all the AT&T customers, you have to talk to AT&T and they have to funnel it through their backend. So, okay. As I mentioned a number of times now, the framework can install, update, uninstall bundles dynamically. And I must say that dynamically is really it's the cool part about it. That's really the cool factor, to develop applications that can dynamically appear and disappear. And it's quite interesting. There's actually another framework out right now. Try to remember the name of it. It's been published by IBM. It's the they use it as a development tool framework, and I have to look up the name. I don't know anymore.
Taglets.
Sorry.
Taglets. AGLETS. That's
No,
one.
no. It's an IDE framework. They position it competing to JBuilder and all those things. Eclipse. Yes, right. So Eclipse allows you to I've only talked with people, I've never tried it myself, but supposedly it also allows you to extend the IDE platform with additional Java code that you write, and also modules, and it has an interface, and it's very similar to what the OSGi framework is intended to, but they only allow you to specify all those Java components at the startup time, and then they link everything together, and as it starts up, everything becomes hard linked, and the dependencies are more or less set in stone. Whereas with the OSGi framework, the cool thing would really be you can, during runtime, just deploy a new module, and then suddenly a menu pops up in one of your pull-down lists, and you have new functionality deployed. So I've heard people actually talking about using the OSGi framework as core of this development framework now, but that's just been like a few weeks ago, so I don't know if they're really going to do it, but we talked to some people at IBM and they were interested in doing this because it's more dynamic and just cooler. So, okay, again, for management, here it is. So the framework provides the mechanisms, but per se is policy free. And the management policy is provided as a bundle. As I said earlier, it's the management bundle that you deploy. And this is specific to the operator. So whoever, or integrator, whoever basically puts the firmware together that goes on this box. And the management policies can be made and selected by the operator. There is standardized OSGi management bundles from network management vendors, and well, one of them is Gatespace, and I know at least Sun and IBM have another one. And there is also a German startup called, or not startup, they've been around too long now, but it's called Process. They also have a management system. So there is at least 4 or 5 out there now. This is pretty much what it looks like. As I said earlier, OSGi specifies the API. It doesn't really specify the protocol itself. So it would look like this, that we have a management system on the back end, and we have a corresponding bundle that talks to the management system. And then we can implement whichever private protocol, SNMP, CIM, SyncML, between those two. It's a collaborative model. It's more than an applet. It's more than just midlet or whatever let runner. I mean, there's so many different standards with Java for implementing little pieces of code. The idea here is, I mean, bundles are expected to collaborate with each other. Applets don't. I mean, an applet is just standalone entity. You start it, you run it. Those here share packages and they interact through services. And then there is a dynamic registry, as I said, that allows bundle to find and track services and to get notified. So there's all this event mechanism how to get notified for bundles either coming or going. And the framework takes care of all these dependencies. So, and that's a side note. My personal opinion is that the OSGi framework is something that Sun should have put into the Java specification in the first place, because the dynamic class loaders, they were a pretty good idea, but they stopped somewhere halfway through. So the functionality of the OSGi framework is something which really would supplement a standard VM very nicely, and I think it's a nice programming model. And I have started doing almost all my work based on OSGi frameworks. I've implemented lots of weird things on top of OSGi frameworks that have nothing to do with gateways or anything. It's just, I don't know, it's a neat programming model. How this works is, so here we have the stack again with the operating system Java and the OSGi framework drawn on top. And we can load different bundles. Each bundle can interact, as I said earlier, with the JVM, with the operating system, with the hardware, and with the framework. And when we get a second bundle, then those bundles can share packages. So each bundle can load packages from its own jar file or from shared packages. And they can also, through the framework registry, they can share services between each other. If we compare this to other OSGi compared to MIP or Java TV or applet browsers, then in all the other models, for example, an applet can't really access the native code and can't access the hardware. There's all the sandbox model. I mean, you can have signed applets, but I don't know who uses signed applets. I haven't seen one in a long time. So the other thing is you can't really share packages or anything in between. They even typically run on different virtual machines. And they usually don't, or there is no way for collaboration between them. They're only standalone entities. So that's all the things that we lose by not using the OSGi framework. Oh yeah, and there is no management. So the Java application manager, all it is basically just loading the bytecode, executing a virtual machine, and running the bytecode. But it's not really managing it. So we've talked about bundles, so now let's see services. So a service is an object, is an instance of an object registered with the framework. It's typically registered by one bundle in order to be used by another bundle or multiple bundles. And in the following it's drawn as a triangle. The semantics is that it's defined by a Java interface, so that's how you define the service. And you obviously implement it as a Java class. And yeah, the interface definition of a service is typically shared as packages between the bundles, just as an implementation note. Okay, so here we have, for example, we have a bundle and we have a log service. And we have here, for example, an IBM log service that implements the log service. So the top log service is only an interface definition in form of a Java interface file. And then we have another bundle or another class which implements this log service. We can have another log service. For example, we can have a Motorola log service that implements the same interface. And we can have a third one which is just a simple log service that does nothing more than just take the log and print it to standard out. Now, the bundle only gets the log service. And depending on who registered, so there can be one or multiple service instances registered. So what happens is the bundle would talk to the framework and do a GET request on the framework. Basically get service and then specify, okay, I want the service that implements the log interface. And then it gets, in this case, for example, 3 objects back, and it can choose either to use one of them or all 3 of them, or just use the first one, whatever is convenient. But the important thing.
Excuse me, I have a question.
Yeah.
This is like, just like any J2EE specification, right? You have like a interface. Then you have different drivers, you implement register the drivers.
Yeah.
The first question is like, you mentioned about like the registry before. So this information has to be put in the registry, right?
Yes.
And then you can have more than one registry and someone who's going to control all of them and get the data, at least conceptually.
You have one registry.
One registry.
Yeah.
How are you implementing that registry? I mean, like, how is the, when I say the implementation, meaning, because there are two ways. One is like, if you take the web services, like they have, for example, EBXML registry, right?
Yes.
In the EBXML registry, you publish the data, all the XML files, and then you have like some sort of like a metadata. You query the metadata from that's going to go and like get actually the data and then like send information back, just like the way you're doing the query. So how is the registry for this? Is it like a flat file kind of thing, or is it totally independent of implementation?
So the registry, it's part of the framework implementation. So it's only specified the API for the registry, like how you register and how you look up services. Typically, this is not stored in a file because typically this is just transient data. After the framework starts up, bundles start to register and start to look up services. But as soon as the framework shuts down, there is no real need to keep the data persistent. So it's typically only stored in RAM. And the query language is LDAP based. So.
Okay. The question that guy asked before about the versioning, why can't like, because when you get the query, I'm assuming the information you're going to get back is like metadata, right? I mean,
yes.
Like if a query particular thing, like, when you have the metadata, like, what's the structure that's going to be, like, what are the functions it's going to support, so on and so forth, right? In such a case, when you no, at the log level, why can't you have like, when you get the object, right? I mean, if you have two different versions,
yeah.
You can have like, you can display to the end user like these are the two, I mean, like, two different versions or two objects existing for this particular type based on that thing. Because I'm assuming like, first time you query the registry and get like the information about the object. So you know the syntax for that object, doing a reflection or whatever. Then you can build the second time you actually invoke the call.
Yes.
So when you're doing the first time, why can't you choose what version you want, and in the second time, like, for that particular object, for that particular version, why can't you invoke the method?
Okay, so let me explain how it works on an API level, really. Because I think it works different from what you expected with the J2EE registry. So the assumption here is that the bundle was implemented and compiled against the interface of the log service. So it doesn't need to do reflection or anything, because when you compile it against the interface, you can just do regular method calls. So you assume that you know the interface when you do a get on the service. And you get the service actually by giving either a reference to a Java interface or giving the textual string name of the interface. And then you get back an array of objects with the results. And the results you can annotate them with, as I said, when you register a string, when you register an object in the registry, you give a string with properties. And one of the properties can be, for example, a version number. So when you look up a service with a specific version number, you can specify which version you want. And if you don't look for a specific one, then you still get all the strings back. So you can, if you get more than one, you can, for example, choose to use the one with the highest version. But it's actually simpler than it is with J2EE, because you don't have to worry about not knowing the interface of the service.
That's the question. Like, I mean, the method invocation you're making, whether it has to be static or it can be dynamic also. So if it is dynamic, then you can get the version number and from there, like, because when it is dynamic, you don't have to know upfront itself, like, what actually the object is. First you make the call, then, like, get the reflection, then you invoke the method, right?
Yeah, well, so when you create the bundle, say you implement a bundle against the log service, you would in your build environment, you have a version of the log API, so you have the log interface, and you compile everything, and then you wrap it together into a bundle. And say in the one case, you do not include all the log API Java interfaces. So for example, you have something like OSGi.framework.log, which specifies the log interface. You leave out this package and you package everything else together. Now if you would start this on a standard virtual machine, it wouldn't execute because it would basically give a class not found exception because it doesn't find the log service. And that's where you would need all the introspection mechanisms. In the OSGi case, you would specify in your manifest that you need the OSGi.framework.log package. The question is, where is it coming from? So in order for this bundle to start and to not fail with a class not found exception, some other bundle must have been started before, which had this implementation, this package, and which exported this package. And in this case here, this would be the log bundle up here. So this log bundle would bring the implementation of the interface, or the definition of the interface. So this would contain the class file with the interface definition, and the other bundles here, like the IBM log, would contain an implementation of this interface. So you would actually, both the IBM log bundle and the client bundle would import the package exported by the log bundle. So they both have access to the class file, which defines the interface. And then when you do a lookup, you get an instance of an object which has been instantiated and registered from this bundle here and put in the registry. And then you can class cast this object to the log service class that you have imported, so the class which was part of the package that you imported from this one. I agree it's a little bit confusing, but it's actually easier when you see it in code. So, I don't know. Oh, there was another one of those funky presentation thingies. So that's what the interface definition looks like, just in case. It's public interface log. As I said earlier, different bundles can implement the same interface. We've gone through this a number of times now. The OSGi defines a standard set of services or a standard set of interfaces, and we have notification for lifecycle events, and each service has a unique ID. That's just another way to represent services. We did this in the specification and a little bit in this presentation here. Basically, each object that implements a Java interface can be registered, unregistered, or modified as a service, and other bundles can actually get the interface. And we have typically one person or one bundle registering it, and we have multiple bundles looking it up. The registry, so there is one registry, and this registry is available to all bundles, and it's here in order to collaborate with other bundles. It requires permission to register and unregister objects, check through the Java 2 security APIs. And the services are annotated or associated with properties. And there is a query language available, which is very close to LDEP to find services. And bundles can update the properties as needed. Yeah, service factories is another tricky implementation way, because we have seen before, we have one object which gets registered and multiple bundles can look it up. Now if you want to have customized object for each client that looks it up, then we can use service factories, and we can customize the service per bundle. There is a service factory interface, and it allows a bundle to return a customized object for each request. And the framework then calls back this factory every time for a get or unget. So in this example, there is a standard bundle which registers a framework service, and we have two bundles looking up the same service, and they both get a reference to the same service, to the same object. Now in the factory case, we have a bundle that registers a factory, and it doesn't have an actual instance of an object. Now bundle A wants to get a reference, and then the framework actually calls back into the bundle factory, which then creates one and hands out a reference. And bundle B asks for a reference. There's a callback to the factory. We create an object, and then bundle B gets a reference. So you can use this to do dynamic proxy generation, like on-the-fly code generation. And then we can manage dependencies between bundles. as soon as bundles have references to other objects, there is dependencies, and if I uninstall a bundle that another one has a dependency on, then I must notify this one. And that's the whole event mechanisms. So bundles which are installed and started will create events to other bundles to either indicate that they become available or that they're going away. So here, for example, we install a new bundle which creates events that this bundle has been installed, and interested bundles can get notified for that. Then this bundle gets started, which, in this example, it gets a service and it registers service on its own, and then bundle B receives an event that bundle A has now registered a service, which can, for example, trigger bundle B to get the service. So this could be that a bundle has started and it runs with minimal functionality, and then suddenly, for example, say a printer comes along and registers a printer service. And bundle B didn't really have a printer service, but it was waiting for one, so it was registering to be notified as soon as a service comes along that implements this. And then now that the service shows up, it can actually go and get the service. Now the problem is when we stop bundle A, then we must notify bundle B that the service is going away. And the bundle B receives the event which says the service A is unregistering. And then bundle B can actually give up the reference, so it doesn't unget on the service and it doesn't have a reference on bundle A anymore. Be uninstalled and go away, which causes an event telling everybody that it's gone. Yeah, that's another example with publisher. I don't want to go too much into details. How do we find a service? So we have seen talking a lot about using services. How do we find them? Well, as I said, we have an LDEP syntax to look them up. We have search properties on a service, which typically include the interface, the Java interface, as a package name. And the filter syntax allows, well, fairly complex expressions based on and or not, less, greater. We even have an approximate, which does a sort of a lexical comparison. And yeah, one thing that I want to refer to here is it's a little bit like Gini. Back in the old days when we defined OSGi, it was internally at Sun it was competing a little bit against Gini. But the difference to Gini is that first of all it's designed to, based on RMI, as I said earlier, it's designed to be more distributed. And it's Gini is also, for example, here with the lookup in the filters, Gini only required you to look up things by interface. You couldn't specify any other properties, and you couldn't specify any comparisons in Gini. So that's what we fixed in this one. And the filter syntax can also be used in the applications. It's an API which is available to applications to use. Yeah, I don't really want to talk about the service tracker. It's the service tracker allows to. It's an API which allows to keep automatically track about services coming and going. It simplifies the implementation work quite a bit. So that's more an implementation tool that people can use when they implement applications on this. I've been referring to this earlier. Java applications typically consist of classes placed in packages, and Java searches for a certain class, usually in its class path, defined through the environment variable. And applications can extend the search path with dynamically created class loaders. And this last bullet item is something that most people who write Java code just overlook, and very few people use actually dynamic class loaders. But that's something that OSGi is very central, built around. So this here is, I mean, that's more or less a little Java overview again. Java programs are typically organized in different packages, and a class name, a class is always defined in the context of a package. So here, for example, we have a package called Ericsson OSGi Profiler, and we have a class X. Then and this is actually called Ericsson OSGi Profiler.x. I mean, that's standard Java. Java package is an indivisible unit of a set of related classes. Okay, so I think this one is the. In OSGi, each bundle has its own class loader. And as I said earlier, typically each bundle can only access packages from its own class loader. The only way how we can share or access other packages is if they are declared as either imported or exported in the manifest. And we also have to have permission to do this. So this is again the fine-grained permission check. The framework itself manages the class load. So each bundle has a different class path when it comes to it. I mean, it's like each bundle has a default class path, which is its own jar file, and then it has all the other packages added to it, which is either imports or exports. And it assures that all bundles use the same class path. The same class is, as I said earlier, there is probably the most tricky exception with OSGi applications is the class cost exception, because I've seen many people basically making the mistake of bringing all their own classes into the application, and then you can end up in a situation where you have different implementations for classes, or even the same implementation just loaded out of different files. And then you try to assign them or compare them, and you get class cost exceptions. And you do a stack trace, and they all look the same, and it takes them usually an hour to figure this out. It's an interesting bug. And the framework tries as much as possible to prevent this, which, yeah, usually works. And it also tracks the dependence of packages between bundles. So, for example, here we have an OSGi class path. We have the standard class path of the OSGi framework, and then, for example, one of the standard services, which is here the OSGi service HTTP. And then bundle A might actually bring a log service and export the log service. It also might bring an implementation of the log service, which is here the IBM log service. And it might bring some classes for IBM J9. It, in this case, imports the HTTP service and the JavaX servlet HTTP. Most of the classes, for example, here the HTTP service can be loaded through the framework class loader from this package here. Now we have a bundle B. So the problem with this one is that the JavaX servlet package, for example, was not available because bundle A tried to import it, but the framework did not export it. So the bundle A could not be started. Now after we install bundle B, which exports stuff like Ericsson OSGi, but also javax.servlet, now we see that this dependency can be fulfilled, and JavaX servlet HTTP is exported by bundle B and imported by bundle A. So bundle A is now, as we saw, say, resolved. It has all its dependencies resolved, and it can be started. And bundle B, so we continue linking this a little bit further here. So now bundle B basically gets all its dependencies resolved, for example, from an export from bundle A. And then bundle B is also ready to run and could be started. So those are the dependencies that the framework kind of keeps track of. Yes?
Going back to the life cycle of a bundle, when you stop a bundle, but another bundle has done a get, and they let's say, didn't do an unget, can you uninstall if another bundle is already?
Okay. So there is a few cases. So there is the one case where the two dependencies is a package dependency and a service dependency. So what you referred to was the service dependency. The service dependency, if a bundle does not give up a reference and it does not unget the service, it's actually even more drastic, because when a bundle does a get, it gets an actual object from the framework, which this object has been instantiated from the class loader of the bundle that registered it. Now, this object you can call methods on, you can do whatever you want on it, as long as somebody has a reference on this object. And for example, bundle A registers it, bundle B gets it, bundle B now has a reference because it's sitting somewhere in a variable, it has put it in a hash table or done whatever with. As long as there is a reference, a Java reference to this object, bundle A can it can go away and it can stop working, but the problem is the class loader cannot be garbage collected, and this package cannot be garbage collected because the VM only garbage collects when the last reference was given up. So bundle B has to voluntarily give up the reference. And so typically what you have to do is you have to, for example, when you assign it to a variable, you have to just override this variable with a null pointer to make sure you have given up the reference. And then you inform the framework and you say, okay, I have given up the reference, and then the framework will start the garbage collection. So that's the unget. Unfortunately, if you have either maliciously or out of, having a bug in your software, you call the framework and you tell the framework, yeah, I have ungotten this, but you actually still have a reference somewhere deep down in your code. The framework will try to do a garbage collection on the class loader and on the package, and it cannot garbage collect it. So this would be the case when you actually have a memory hole. And unfortunately, we've tried various things, but there isn't really anything that the Java VM allows you to do, because we would basically have to we would have to change the garbage collector implementation of the VM to allow to withdraw, basically forcefully withdraw objects that still references exist, and then maybe next time you use the reference you would just get like an invalid pointer exception or something like this. But unfortunately Sun wasn't very cooperative changing the VM.
Have you looked at the upcoming application isolation
No.
information?
No.
I can tell you more about it.
Okay, good. Yeah, I mean, one of the things how we tried to solve this was if you would use RMI. So that's unofficial here, but what we tried to look at in our labs was to just basically use RMI and create proxies so that you don't hand out the real objects, but you just hand out a proxy object and they interact with RMI. Then you could actually destroy all the packages and all the class information, and you would just have this proxy hanging around, and you would limit this problem because you have like a separate interface. So the package handling here, the package admin service, this actually implements the policy of the package handling. It does the uninstalling. As it says here, uninstalling a bundle will not withdraw export packages anymore. This is another case here, because what I was just saying is the service dependencies. Now the differences with package dependencies, because there, when you export a package and somebody else uses this package, like you instantiate classes out of this package, then what happens is you can't undo this because the classes are around. Even when you try to uninstall this package, you can't force everybody else to give up those instances that they have created. And we have changed this now. In version 1, it was said that you have to be able to withdraw this, but this caused major confusion. So in version 2, the packages will not be withdrawn. They're just around until somebody uninstalls the last bundle. So it's a compromise between really confusing people that implement software and saving memory. Well, it also keeps track of the IM and exporting from the manifests, and it cleans up stale exported packages by stopping and starting the minimum set of bundles. That's an optional feature that allows you to more or less garbage collect bundles that haven't been used. Native code, well, we have, as I said initially, we can include whatever native code we want in a jar file, as long as we know that the platform that it's deployed to supports the native code. The matching of the operating system, processor, and language is actually supported by the framework. So we can have different bundle versions that specify in the manifest different operating systems and processors, and then only the ones with the matching operating systems get installed. The life cycle, as I said, is life cycle of native code is bound to the life cycle of the bundle, which makes it even more difficult because you must really clean up after your native code. And it requires Java 1.2 native code support. So the initial pjava implementation didn't have this, but then there came another pjava implementation that had the Java 1.2 native code support, and it had the 1.2 security support. So that's what we run on. Well, that's how to use native code. Here again to the dependency management. That's, as I said earlier, when a bundle is stopped, it's typically cleaned up and the registered services are removed, which means everybody's notified to give up their service voluntarily, and the references to other services are dropped. And also part of the dependency management is that bundles can be notified when a service they depend on is unregistered. And class path dependencies, that's basically package dependencies, are managed. And this model allows long-running applications with dynamic software updates. As I said in the very beginning, so this was one of the design goals, to really be able to keep the virtual machine running and dynamically load and unload applications. So, well, this is some real code which you can hardly see here. And
it'll be in the archives.
Yeah, but just to basically show, that's like a one-page code, fairly lightly populated, and this is basically a minimal set of a Hello World bundle that just has an activator which allows the bundle to start and stop, and it prints out Hello World when you start it and when you stop it. There is code how to register a service, and so on. Security, as I said, we use 1.2 security. The permission classes are used for this, and well, it does the usual Java stack-based checking. And the remark is that it is a little bit CPU intensive, but it is a very flexible way of doing security on top of Java 1.2. OSGi has defined, on top of this, it has defined one protection domain per bundle. Java 2 would allow multiple ones, but we chose one protection domain per bundle as probably the right granularity, because you don't want, usually you assume a code in a bundle to be friendly. I mean, you don't want to protect yourself from your own code. And this is done through the permission or the security admin, and the framework is agnostic to it. So the framework doesn't really enforce the policies. All the policy stuff is done outside in a separate bundle. It's the permission admin service. And well, this is a nice overview how the stack-based checking of security permissions is done. And well, I believe you can look at this in the archives. Here's some API for this, but that's basically most of the technical. So I don't know, we could do some Q&As. I don't know what you typically what the time frame is.
Do you have any specific examples or anything like that that you can show or talk about?
I didn't bring any demos, but I can talk about examples.
Well, yeah, demos
Yeah.
or slides or whatever. Yeah.
I have one even more technical slide on how to, tips and tricks how to implement stuff on top of this. I don't know what the interest of everybody here is. I can talk a little bit about how devices are used in OSGi. That's like my specialty, where I was doing a lot of work for the OSGi.
What kind of products does Gatespace put out?
Gatespace started as an implementation of the framework specification. In fact, actually, the reference implementation of the OSGi framework is that you can download. Is it actually free for everybody or just for members? The reference.
I think it's free for everybody.
So yeah, so everybody can download the reference implementation, and you can then go and just play around with it. So this has been done by Gatespace, the framework, and what we do for a living, other than writing code that we give away for free, is we implemented a management system for those OSGi gateways. So this was done within Ericsson in a project called the E2 Home project. There is a number, I think you referred to the home in Czechoslovakia.
Yeah.
I know about 2 deployments in, what's the town called? I don't know, it's somewhere in Sweden, it's close to Göteborg. And they have some apartments where they have Java-based OSGi gateways. They have home security applications. They have energy management applications. And they basically run an apartment complex on those gateways. It's a field trial that Ericsson and Electrolux, which is is it a Swedish appliance manufacturer?
machines.
Yeah, they
Yeah.
have put this trial together.
And what does OSGi bring to that that wouldn't be there otherwise? In other words, what's the value of OSGi in that environment?
The value of OSGi there is that you have different appliances. So each house can have a different set of appliances.
Okay.
And you don't need to, when you deploy the home gateways, you don't need to know previously which environment to expect. So for example, somebody hooks up, buys a new dishwasher, and it might have a really cool user interface, but the dishwasher has been manufactured after the gateway has been deployed. The assumption here is that most of those home gateways will have a fairly long life cycle. So the life cycle of those gateways is expected to be somewhere in the 5 to 8 years, sometimes even more. But you need to later be able to deploy new code to those gateways. And OSGi allows you to dynamically deploy new code to those gateways.
Okay.
So this is one of the things that we've done in this field trial. Yeah. Yep.
Another example might be there's such a mixed environment in consumer homes, and you may have an ISP who is looking to start delivering home-based services on the internet infrastructure to the home. And because the home consumer will have a GE fridge, a Bosch dishwasher, I mean, you know, they don't buy a single
KitchenAid dishwasher,
Right.
a General Electric
My kitchen is a
refrigerator,
mixture of all sorts of stuff. We're lucky the colors even match.
Black & Decker toaster.
And that's just the kitchen. So if you add consumer electronics, meters, electrical appliances, I mean the whole gamut of what you can find in a home, it's too overwhelming for anybody to deliver an end-to-end architecture that tightly links all this stuff. So you need a very open-ended system.
Well, you know
So if tomorrow I decide to dump my DSL provider and switch to cable,
Yeah.
and they're both deploy this framework, it's dynamic. It all still works.
Okay. But the guy who's commanding things right now, and this may just be my bias, is TiVo. TiVo has come in and just awakened everyone up to what you can do with video and archiving video and holding it, and playing around with it, and time shifting it, and they're moving out of that into your pictures and your TiVo talking to other TiVos and everything. Well, how does OSGi play into that? Are you guys talking to them? Or?
You know more about that.
TiVo probably down the road is aware of OSGi,
Okay.
just like all the cable set-top box players are, just like Sony is. I mean, if you look at, You know, it's interesting, you know, what could California benefit? You know, just a collective societal good. I mean, clearly, you know, we've had all sorts of problems with energy. But the way we deliver energy today, it's, you get a meter reading and it's one rate, and you look at the clock and you see how many kilowatts you've used and you get a bill, right? Or whatever it is, how many watts you
There's
use.
still a guy walking up the street
There's
carrying a
no
box.
metered service like you have to do for long distance, right? So if we could shift consumption so we don't drain the power grid, we wouldn't probably need to do all the things we need to do. So I'm just going to cite some illustrations. If we had smart intelligent meters and we had a mechanism to shift consumption, we'd have a wonderful kind of smart utility. If we had home security, instead of Wells Fargo Security or ADT doing an outbound call and stealing my telephone signal for a second to call in and then do a callback, again, we could have another internet-based delivery mechanism for home security. I didn't even touch upon home entertainment with TiVo, but again, there's a plethora of applications that could be delivered there. Home automation, home control, home health sensor, you know, somebody that's aged or needs, you know, the alarm system. Help me, I've fallen and help me.
I can't get up.
I can't get up.
Don't show me that again, please.
Yeah, there's just so many applications. I mean, we're probably 10 years away from a GPS-based sensor, so we don't have any more 6-year-olds kidnapped. And it'd be nice to be able to capture that, you know, right away. So, I mean, there's a ton of applications. The thing is, if you're ADT, they didn't build an end-to-end infrastructure. They stole the telephone call. They would have never deployed a home security system if they had to send out a crew to trench wire to your home.
Well, there are guys that are running dry lines for those.
So I think the OSGi story here is to develop an open framework, regardless of the transport, regardless of the services, and create some sort of, you know, dynamic
We got
software
a question
framework.
in the back there.
So I'll answer your question another way. Another popular application for OSGi appears to me in the automotive and telematics space.
Absolutely.
Just as there are trials underway for home-oriented things, there are also people who are putting this in cars. You can imagine that. So they're taking an embedded compute platform, Shake and Vibe, Ready, and they're embedding it in cars as a way to deploy services to the cars to meet the demands for vehicle drivers, safety security, diagnostics, maintenance, traffic and navigation. You can put a display on it, you get your navigation stuff, etc. So it's another kind of practical use. And from what I can tell, some of those field trials looks like they're going to go into vehicle lines in 05, 06 in consumer cars.
Yeah, I know I think all of the European car manufacturers are actually looking into this, and they're very actively participating in OSGi. I know that IBM, I don't know who's working with them actually. I have to take back the IBM, I don't know for sure. But I know...
Yes, they are.
Yeah. But I know that, for example, BMW is contributing quite heavily to this area.
I know the BMW guys are contributing. I know also Acuna out of the Netherlands, they're driving some of the pilots. Acuna is partially owned by General Motors and OnStar, so they're potentially partnering with OnStar in Europe.
Yeah,
OnStar,
There's a wireless car, there's a bunch of other kind of people involved with the pilots for that.
Cars will be easier to implement because typically it's a you know, the manufacturer controls the environment. It's not like we go out and buy all this different stuff and throw it all together.
Technically, I would agree with you that it's easier for cars technically. I think the problem the car guys have are the business model behind it. What's the recurring revenue stream? How do they justify the expense of a embedded compute device in the vehicle? You know, in the ubiquity play market where everybody has cell phones today, right? So
They have a much harsher environment. You know, you can't think of it. If you're building hardware, you got to think about their environment. It jiggles, burns up, it freezes. It does a lot of strange things. Falls.
Well, there are electronic suppliers to the automobile industry that know how to build components for cars. They are building the platforms that the cars
Is Bosch still a member? I think Bosch is a member.
Well, they are part of VDO now, isn't it?
When I sat my car on the tarmac in front of the Las Vegas Convention Center, it was my VCR that failed, not the car.
Yeah. No, but That's a big push in OSGi right now. It's about as big as the home gateway market is the car industry. And I mean, I know Acunia, they're very active. They're pushing their own agenda there as well. And AMIC, for example, on the US side is also a member of OSGi now. And they're more observing. It's another big standards body, but they're very aware of it.
Actually, I think probably most of the automotive initiatives really on the OSGi side. I'll tell you, the AMIC guys are interested, but there's really not a lot of flesh behind what they're trying to do. They're There's more auto guys in OSGi than there are in AMIC.
I think the jury is out on this, what are the additional revenues? I mean, I don't know, is Cirrus and XFM going to make it? Do people really want to spend a whole lot of more money just to get more
Well,
radio
I think
stations?
that's the discussion to have. Is
yet to be seen.
Aftermarket right now, the guys from Cirrus, the digital radio stuff, the aftermarket nav players, $900 to $2,500 for a DVD player in your trunk and a screen. I mean, those guys are all on the decline right now. So it's guys like Telematics and OnStar that are perceived as being able to get that business with this third generation platform for telematics.
Yeah. I mean, we had talks initially with guys like OnStar, and I mean, it's just a matter of a business case for them. How can they benefit from the Java environment? And somebody has to find a business case.
Right.
Yes.
To make all the gateways work, you need IP numbers. Where does that fit in with the OSGi? Is that some other level?
It's below. It's in the operating system. I mean, OSGi, it's more like an application server specification. But what you can do is you can have bundles that through the native interface can actually do, for example, a setting of your NAT, port forwarding, firewall rules, and those things. So we have, within Gatespace, we have one, what we call easy home networking setup, where you have a management system on the back that deploys the firewall bundles. It deploys, so you have a gateway which ships fairly naked. It's in our case, it's a Linux platform with an OSGi framework on top. And then the management system, so you subscribe, oh, I want so initially it just does NAT and nothing else. And then you say, oh, I want firewalling. Then we just deploy a little Java code to your gateway, which knows how to talk to the IP filters to set up the firewalling rules. And then you can do that. Or you can say, oh, I want to have application proxies for instant messaging. And then it deploys a Java bundle, which is more or less just a wrapper around an application proxy that gets linked into your firewall system. So you can do those things, although the question is, if you only do that, it probably doesn't justify the overhead of an OSGi framework. So it's like a benefit that you can do in addition. If you've already made the decision, I want to go OSGi, you can do this in addition to the application server.
Christian, thank you very much.
That's really good. Thank you.
It's a very detailed presentation. We like to recognize the effort, and your effort is substantial. So thank you very much for spending the time and putting all that time in.
Oh, thank you very much.
65 foils.
Oh, I didn't show all of them.
You didn't show. The ones that he did show will be up on the site as soon as he can get them to me.
Okay.
Does anyone have any announcements they want to make?
When are you looking for work? And we have an analytical startup based on the analytical project, and we have clients who are very excited about it. So if you're perhaps interested in work, please come talk to me. And,
what skill set are you looking for?
Well, I'll talk to them about that. I have quite a list here. Java, C, C++.
Engineers, program developers.
Developers, for the most part, but not totally. We're looking for artists, for example.
Okay. Someone who can, all kinds of development. Any other announcements? You were going to say something.
We've got the Internet World Essentials is down in South San Jose at the San Jose Convention Center. I think if you go on the webpage, www.iw.com, I you put code S2 or something, you go to the exhibits for free at least. And, there's a lot of Selmeier I guess they're required to phone in for that. So. And there's also the RSA data back up in the Scouting Center. All happening this week. So, a lot of stuff going on.
Okay. I'd like to say that I am really excited about the kind of session we had tonight and about the ones that are coming up. We have some very interesting topics. Our speaker next time will be, and you bring me all the topics you want, I've already got the next 3 lined up. The speaker next time is going to be the gentleman who did the Twiki. I don't know if you know what Twiki is, but it is one of the leading collaboration tools, web-based collaboration tools on the net that you can get on there, identify under a controlled environment, interact with each other in a development project